Lab 2 is about designing a cam. The objective of this lab is to design, fabricate, and test a cam addressing a specific required motion. A cam is a common mechanism that drives a mating component known as follower by means of direct contact between the cam and follower. Depending on the different type of motion, a cam profile could be devoted to provide different regimes of motion. So these are the cams, an example of a cam, different shapes. The circumference of these cams are the one that you're going to design in order to achieve the displacement profile of the follower. The apparatus in this video is the mechanism to test the cams. It consists of a vertical frame supported on a horizontal base board. The frame carries a spindle on which is mounted a circular scale graduated in degrees. This is the cam that we have. So any of these cams we can go and install here. So any of the cam that we have here, we will install it here, and this thing on top is called follower. Once I tighten this, we are able to turn this. We are able to turn this to different degrees here, all the way through 360. We have to note that once this is at the 0, this reading shows the displacement, vertical displacement of the follower. So if it goes up and down, you will see different things. So once the cam angle is at 0, let's turn this so that it starts at 0. Cam having various profiles can be attached to the spindle and scales by means of the two wing nuts, so that when turned by hand, cam and scale revolve together in a vertical plane about the spindle axis. 3 brass clips having reference lines engraved upon them are located on the frame disposed around the circumference of the scale, so that readings of the cam rotations can be obtained regardless of the angular position of the cam. The follower consists of a square section steel rod sliding vertically in 2 guides and a spring loaded to bear on the edge of the rod passing through the axis of rotation of the cam. So the procedure for this lab is as follows. Each student groups will receive a design data for a cam. So you will receive a set of requirements that based on those you will design these cams. Plot displacement diagrams and a cam profile in AutoCAD software. Fabricate your cam from a plexiglass with a thickness of 3/16 using a laser cut machine. Use one of the existing cams of the apparatus to find the drill pattern. So there's one hole here for the center hole, and there's one here on top, so that it makes sure that both of them are here in order to have the cam on place. Attach your cam to the spindle and circular scale by means of 2 wing nuts, and insert the knife edge follower in the slotted end of the rod. So we're going to put this right here. Make sure this is at the 0. Revolve the cam by hand until the 0 of the circular scale coincides with the index line on the frame when the follower is at the lowest position. So lowest position here. This is here, good. Again, make sure this starts at 0. Turn the cam through an angle of 10 degrees and record the following movement in inches indicated on a scale in a tabular format. Okay, so let's have this. We're going to turn this to 10, and we're going to measure how much it was from 0. So from 0 here, we are 90. Then next one, 20. Now is 128. Next, 30, all the way to the end. Plot the experimental displacement diagrams and compare with your design. So when you design the cam, you have the calculated cam profile. Now we have the experimental. The purpose is to compare and see whether we achieved it.